I'm going to talk briefly about some of the work that we've been doing at the Getty Museum in 3D scanning and its applications for mount making, conservation, exhibitions, and packing. So over the past 5 years, the Getty Museum has been researching the viability of 3D scanning for mount making, exhibition, and other related projects. Starting with the very basic equipment and software, promising results were soon achieved. This led to further investigations, better equipment, and ultimately improved results. This presentation will outline the various past successes, failures, and the future with 3D scanning at the Getty Museum for these different projects. When we first started to look at the options, the choices of scanners were pretty narrow. Most were very expensive or limited to small size objects. The first scanner we tried was from a company called David Scanner, which utilized a gridded background, a laser, and a webcam. The cost of the setup was very affordable, and the range of object sizes could be scanned was pretty versatile, all of which made it an attractive option for us to start with. We soon learned that the setup was adaptable, but the need for a gridded backdrop proved to be an inconvenience, especially with larger objects. And you can kind of see that there in the background of that one image. Subsequently, we discovered a scanner that is designed to be used with an iPad. The structure sensor fulfilled many of the requirements that we were looking for in a scanner that was portable, didn't need a backdrop, and was simple to use and affordable. The scanner uses a projected infrared pattern to determine the shape of the object that's being scanned. This is a real plus in low light situations. Also, we found the scanner could work through vitrines, so objects on display could be potentially scanned in situ. The structure sensor also uses open source software. This has resulted in a number of available scanning apps with different features. After many test scans on various objects in the museum's collection, we quickly discovered that the strong points and limitations of the system. Since the scanner is a low-cost system, the overall resolution is not very sharp. This results in a softening of the detail. On larger objects, this isn't necessarily a problem, but on smaller objects, we found that the softening can result in unusable scans. The scanning system can also be used in conjunction with a computer running a more powerful scanning software called Scanect, which is included with the purchase of the structure sensor scanner. The scanner can be used wirelessly with the iPad, with a Wi-Fi connection, or with a tethered connection. While experimenting with the various scanning setups, we were also looking at the practical uses of the scans that we were getting. This ranged from material stress analysis with a program called Scan and Solved, designing structural supports, mounts, and mount fabrications using the software called Rhino 3D. Other programs such as Mesh Mixer and Mesh Lab have also been useful for editing and preparing scans for printing. This process was slow to start, but eventually we gained momentum, and in the beginning, useful scans were time-consuming and not very practical. But as our equipment improved, so did the number of useful scans and our proficiency with the various 3D softwares that we were using. In 2014, the museum was faced with a challenging project that involved a monumental bronze statue from the, excuse my pronunciation, the Kunsthistoric Ephesus Museum in Vienna, which Rita and Vincent talked on briefly with the shipping. This monumental bronze was to be included in a traveling Hellenistic bronze exhibition that was going to be eventually at the Getty Museum. The statue required a specially designed lifting and traveling support due to its fragility. While the Getty Museum had previously fabricated a number of these supports for statues in its own collection, this had never been done remotely without the object. Fortunately, the Lending Museum had recently commissioned a 3D scan of the statue, and it proved to be, and provided it to us for reference. This turned out to be a pivotal point in the project and for our understanding of future potentials of 3D scanning and modeling. We found that using the scan in the Rhino 3D modeling program provided us with a new level of design capabilities. We quickly found out that not only could we design the complex support structure, but also the numerous conformal supports that would contact the statue. And it looked like that this could all be done in advance. Not completely sure of the accuracy of the provided scans, the idea of prefabricating a few of the components in advance and sending them to Vienna to have them test fitted was decided. Once the supports were machined from a high-density polystyrene foam and were sent to Vienna for test fitting, and we found that they matched the corresponding areas of the sculpture exactly. At that point, we felt confident to move forward with our plan of prefabricating all of the components and sending them to Vienna to be assembled around the statue. During this process, we found that virtually every part fit as planned, which has never happened for me. So, after this success of this project, greater emphasis was placed on the use of 3D scanning and its possibilities. With a number of 3D printing services that are now available, we began looking into the possibilities of having mounts printed, since many of them offer stainless steel as a material option. And our colleagues at the Smithsonian Institution have been investigating this as well. And after further investigation, it was found that the stainless steel options is a composite and not a traditional alloy, which raised concerns about material strength and workability. But it does seem that better options might be available soon. Also, the cost of having some of these printed in metal seemed to be cost prohibitive. Because of these issues, we decided to pursue a different process of using 3D scans for mount making. We soon invested in a small 3D printer that would be able to print full-scale models of scanned objects. This would allow us to make mounts as if we had the real object, using traditional fabrication techniques and materials. The printer that we purchased turned out to be fairly easy to use and operate, but did have a bit of a learning curve when it came to printing certain shapes. But after a few trial and errors, we started getting good results. There was also a new piece of software to learn with the printer. Turns out all printers operate using a slicing program, which takes the scan and slices it into thousands of paper-thin layers. But fortunately, the program was very easy to use and wasn't a problem. So the question is, why go through all this effort to make a mount? As everyone here knows, we're faced with multiple challenges and multiple exhibits every year, which include many, many lone objects. And since the Getty Museum is located in a highly active seismic region, we are faced with making sure that all of the objects that we put on display, as well as on storage, are secured in a manner that will minimize potential damage from an earthquake, which adds a whole new level of complexity to the mount designs and the exhibition schedule. Since loan objects usually arrive days before scheduled installation time, time to fabricate mounts for these artworks is limited or non-existent. So with larger exhibitions that include many 3D objects, when appropriate, we'll try to see as many of these artworks as possible before they arrive for installation. This gives us an opportunity to get a head start on as many mounts as possible before the craziness of installation begins. In the past, we would use various approaches to acquire dimensional information on an object, everything from paper templates, making casts, bringing metal and tooling so we could start fabrication on site while we still had access to the object. All of these techniques worked fairly well within a reason, but required traveling with lots of heavy equipment and might only allow us to begin a mount instead of having a fully finished prefabricated mount ready to go. As our results improved with 3D scanning, we felt confident enough to try it with an upcoming exhibition. The exhibition, focusing on the 18th century sculptor Édime Bouchardon, gave us an opportunity to try out the 3D scanning and printing method for our prefabrication process. Using the structure sensor, an iPad, and a laptop, We traveled to the Louvre Museum during the installation of the exhibit there, where we had access to many of the objects before they were installed. Still not feeling 100% confident in this technique, we still took paper templates and many measurements in our old methods. In the end, we did end up scanning all the intended artwork, and we used the iPad scanner for that process. Once back at the Getty, we were now tasked with going through all of the raw scans and cleaning them up. This process ranged from fairly simple to very time-consuming. But in the end, all the scans cleaned up quite well. The starting point for cleaning a scan required it to be imported into the Rhino program for scaling. This is important because the iPad scanner uses meters as its measurements. The printer uses millimeters, so we want to make sure that everything's in the same scale. But fortunately, this is a very easy task. Once the scans were converted into millimeters, they needed to be cleaned up, have the orientations adjusted, and made watertight before they could be sent to the printer. Also, if the object was large, the scan could be cropped to a manageable print size. There was no need to print the entire object when we were only focusing on certain parts of the object. We found that a free software from Autodesk called Mesh Mixer worked quite well for all of these steps. After the scans were cleaned up and ready for printing, the files were imported into the slicing program and then sent to the printer. Depending on the size of the object and the print quality on the printer, a scan might take anywhere from 1 to 12 hours to print. Once the print was finished, a bit of cleanup was involved to remove any temporary supports that were made by the printer to accommodate overhangs. Then the printed sections were used as stand-ins for the real object, and then we could start making our mounts. We went through this process for about a third of the 25 objects that were in the Bouchardon exhibition, and it allowed us to have many of the smaller mounts prepared for the artworks before the installation began. We didn't print models for everything. Some of the scans that we used were used for designing structural supports and larger mounts, and the next few examples will show how well this process worked. Here's a monumental copy of the Barberini fawn, which was also by the artist Bouchardon, that was in the exhibition, and it was one of the centerpieces. A scan was taken of the entire object and of its existing base mount. We used the scan in the Rhino program to estimate its approximate weight by using volumetric calculation. That's part of the program, and then we multiplied it by an average weight of the marble. This was very helpful since the lender didn't have a weight for the object, and we needed that to provide a proper support for it. We also used the Rhino program to design this concealed steel structure that you can see here, and it was also used to mate up with the existing steel base that you can see right here. This came with the object, and then this was everything that we provided, but it was all based on the scan and then the design of the furniture. The other example is this large-scale statue of the Virgin Mary from the Church of Saint-Sulpice in Paris. Is also by Bouchardon, which we used to design these supports in Rhino. You can see right here, there was a bracket here, and the detail. So you can see that we're getting pretty good results. All of this required minimal adjustment during the installation. The rest of the scan objects had various levels of successes, and I will try to touch on what worked and what didn't. Nothing was a complete failure, but there were prefabricated mounts made from prints that needed quite a bit more adjustment than we were hoping. There were a few contributing reasons for this. One was our scanner. The structure sensor scanner, as I mentioned, it has its limitations in terms of the resolution And then you can see here that, it does a good job, but it softens the features quite a bit compared to the real object. And we found that with objects that were under a meter, that really became an issue, that softening. And over a meter, it wasn't quite so much of an issue. There was another problem as well, and that happened in the cleaning process. And that was more of where we found that when you're removing a lot of the extra background that might have been captured at the scan, you might end up removing just a little bit off the bottom of the piece, and that could result in where a clip might not fit as well as you would intend it to. So I think in the moving forward, we would keep the ground actually in the scan and work with it as an attribute instead of noise. But we did have some really great successes with within this exhibition as well, using the scans. This mount here was prefabricated completely from this scan here. Instead of printing, because of the size of the object, it was decided just to create a profile template from the scan, and then this was fabricated from this template, and we found that it fit without any adjustments at all. So the Bouchardon exhibit ended up being a really great first effort for us with using 3D scanning and printing as a means for preparing for an upcoming exhibition. And despite some of the failures, nothing, as I said, was a complete loss. And it did save us many, many hours of stress that we would have been trying to accommodate during the installation. Moving forward, the Getty Museum has made a commitment to our work in 3D scanning and has funded the purchase of better equipment, which we're just starting to learn how to use. 2 new scanners were acquired, one that works very well with smaller objects, the other with larger. They're both from a company called Artec. This one does larger objects, this one's for smaller. And they're interchangeable during the same project, which is great. So you could potentially scan a large object and then come in and get higher detail with the other scanner. So here's a few examples just to quickly illustrate the difference in scanning quality now that we should be getting. This is with the iPad scanner, and this is what we are going to be getting with our new equipment. The new scanners, because of the cost involved, are being shared now between the museum's objects conservation labs and the preparation departments. But we have high hopes that, that this equipment will benefit for various projects. These few examples here too, this is what we're going to be able to, what we're printing now, the quality of prints that we're getting from, this is the real object, this is a print, the front and back, and same here. These are very small objects, and this level of quality we would have never been able to get prior with the prior equipment. Well, while scanning offers many advantages, there are downsides. Variables such as cost, equipment, accuracy, time, and challenging objects such as highly reflective or transparent objects all contribute to the levels of success using this technique. Despite these drawbacks, 3D scanning does offer many benefits to the museum. And with the constant improvement in technology, the cost of better equipment will become more affordable and accessible. Thank you.